Hi guys, in the previous session we discussed about the moment of forces and the torque. Somebody asked in the comment box that what is the difference of moment and torque. Actually here we are trying to focus on the class 10 syllabus, that's why we have not discussed, and as per class 10 we can assume that moment of force and torque is almost same. But there is a little bit difference, that is moment is the static condition. When a body tends to rotate, then we consider moment of force. But when it is in dynamic equilibrium and a force acts on it, then we may have the dynamic inequilibrium, and in that case we consider the torque. Okay, but the measurement is same. But our today's topic is the center of gravity. What is center of gravity? Suppose this is a lamina. Lamina means this is area and thickness is very small. That's why it is called lamina. Now it consists of infinite number of small particles. Okay. Suppose we consider that all the mass is concentrated in a particular point. This one, suppose that mass is concentrated in that particular point, the effect will be same. That means the moment of all those forces, suppose this is a vertical line, okay, towards center of gravity. So the moments of these vertical weights of these point particles try to rotate the object in this direction. Okay, but moment of these weight of these point particles try to rotate the object in this direction. So some of these moments try to rotate in what direction? Anti-clockwise direction. But some of these moments try to rotate the object in a clockwise direction. Okay, but if the total moments are same, then it will have no motion. That means it will be in equilibrium. Okay, so if we consider here is a point in this line anywhere, suppose there is a point in this line, the moment will be 0. Total weight of the body is W, suppose. So the moment for this total weight about this point will be 0. That means it is considered, this point is considered as center of gravity. Now center of gravity lies in this straight line, in this axis. But where? It could be here, anywhere. So we have to move the object in some other direction to find out the center of gravity. Okay, let's have an example. This is an irregular lamina. Okay, irregular lamina. Here are some points, some pinholes are there. Okay, now suppose I suspend a weight through that string vertically downwards. Okay, the weight act vertically downwards. Okay, that means center of gravity, if we allow the object to rotate, sometimes it will must come in the equilibrium state. So this is equilibrium and this is a vertical line. So the weight must lie, the center of gravity must lie in this straight line. Okay, now draw this straight line. Okay, this is the straight line I have drawn. Now take some other points. The same experiment is repeated. but the point is different. Okay. Similarly, the center of gravity lies in this straight line also. So if we draw a straight line, the point of intersection is here. That means center of gravity is the common point of these two straight lines. Thus, we can find out the center of gravity of any irregular object. This is another third point also, we can do it, same experiment. We will see that this center of gravity also will pass through the center of C, through almost same. Okay, minor error is due to the okay. So thus you can understand center of gravity, because the mass, if we assume the mass is concentrated in this point, and if we take the moment about this vertical line, then we will get the moment, the weight of the object into the distance of the perpendicular distance of the point of pivot or point of center of gravity, that is 0. So 0 into the weight, 0 into weight is 0. So total moment is 0. Thus we can find out the center of gravity of any irregular lamina. Okay. For some regular shape, suppose this is a rectangle. If it is 3D, then it will be a lamina. Consider the lamina only here, because our syllabus is based on the 2D shape. Now if we try to find out the center of gravity, we will get the center of gravity at the intersecting point of the two diagonals of that lamina. Okay, so this is the center of gravity for a rectangle. For a circle, center of gravity is here. So for a ring shaped any object, the center of gravity is here. For a disc, center of gravity is here. For 3D shaped sphere, center of gravity is at the center of that geometrical center of that sphere. For a rectangle, for a triangle, now this is a scalene triangle. So for the scalene triangle, we have to draw the medians. This is the midpoint, join the vertex and midpoint. So the median, the intersecting point of the three medians, is the center of gravity. For a hollow pipe, center of gravity will be here. For a solid pipe and hollow pipe both. But remember one thing, that center of gravity may be outside of the lamina, outside of the object or lamina. This is a lamina. Now here center of gravity will be somewhere here. So it is also possible that center of gravity may be outside of the object. Okay. Now today we have discussed up to that point, but next time we will make another video about the other topics. Okay. Till then, goodbye. See you again. Please share, like and comment. If there is any doubt or any new idea, then please comment me, encourage me to make new videos. Okay. Thank you. See you.